Hello student, this is grade 12 biology lesson. Lesson 2, Biomolecules. The main content of this lesson are inorganic molecule, organic molecule. Student, at the end of this lesson, you will be able to describe properties of water, describe structure and the function of carbohydrates. Student, do you know what biomolecule means? Well done. Every cell composed of an assemblage of atom molecules called biomolecules. Biomolecules can be classified into two main types. These are inorganic and organic molecule. Student, do you know what bio means? The difference between inorganic and organic molecule mean? Well done. When we say inorganic molecule, a molecule that contain either hydrogen or carbon, but not both, like water, acid, base, salts, and else. Whereas organic molecules are the most complex and contain large part of the cell, containing both carbon and hydrogen, just like that of carbohydrates, just like that of lipid, just like that of protein, and the nucleic acid are some example of organic molecules. So, life is made from a combination of organic and inorganic molecules. The most common building block element is hydrogen, which consists about 59% of the cell, oxygen, which consists about 24% of the cell, carbon, which consists about 11% of the cell, nitrogen, which consists about 4% of the cell. These are the most common, considered as only elements, whereas sulfur and the phosphorus can be include about 2% of the cell. Together, they are the sixth most important element of the cell to form life, which you call sponge element. Well, let's see one by one. Water. Student, do you know what water mean? Water is the most important and abundant inorganic molecule in living cell and in the ecosystem. It determines physical and chemical property of life. As that we say water is alive. So it is a substance that can exist in three main states: in solid, in form of ice; in liquid, in form of liquid water; in gaseous form, in form of steam at room temperature. And again, all water molecule has the same mass, which is 18 grams per mole. Water is made from two hydrogen atoms when they are bonded with that of one oxygen atom by hydrogen bond. A weak hydrogen bond makes an interaction or that of a bondage between hydrogen and that of oxygen. Water forms a dipole moment with that of this molecule, which takes place between partially negative oxygen and partially positive hydrogen. Water forms a V-shaped structure, not straight, just like with a bond angle of this one. It is very important to living things because it is enormous property. The presence of many property makes water to become most important for life. Absence of water is very difficult for life to exist on this planet. So water has so many properties that serve so many functions for the life. Let's see some property of water one by one. The most important property of water is, one, water has high specific capacity. When we say water has high capacity, it needs high energy to be heat up, and it loses the energy to absorb more slowly. This is very important for life. For example, life that are found in large water body, just like that of ocean, seas in the lake, because water can remain at constant temperature. And again, very important for an enzyme that's found in living thing to be function at constant or optimum temperature. This is what is the importance of specific capacity of water. Another, ice, which is a solid form of water, is less dense than its liquid form, which is unusual property of water. This makes water to become freeze top down. The biological importance of this property of water is water found at the upper part makes an insulator for that of the underneath. This is very important for life to be continue warm one, even though the climate is cold. Another property of water is water has high latent heat of vaporization. Do you know what by means high latent heat of vaporization mean? What do I mean the biological importance of this high latent heat of vaporization? Well done. When you say this property of water, water need high energy to change its liquid form, water, into its gaseous one. Means water doesn't vaporize easily. By that, even though the climate become hot, the large water body cannot be dry easily. This is very important for life found in larger water body to become continue, even the situation is harsh or dry. Another property of water is water has high surface tension, which means there is hydrogen bonding between all sides of water molecule, but not at upper one. This makes the surface water to become hydrogen bonded more strongly. There is no hydrogen bonding from the above, but they can be hold them together. There is hydrogen bonding from all sides of water molecule. This is very important for the life. One, some insects can capable to attach themselves to the surface of water. They can easily walk on the surface of the water. And again, they can capable to walk within a water. It is very important. Why insects walk on the surface of water? Because of high surface tension of water. There is hydrogen bonding from the outside of water molecule, but there is no hydrogen bonding from the surface. So water can hydrogen bond it together. There is no breakage here. A balanced force from all surface of water molecule is said to be high surface tension. Another property, water is considered as a universal solvent, which means most of organic and inorganic molecule dissolve in water, but not all. Water is a universal solvent. Not only dissolving, it can capable to transport the dissolved particle or substance in water-based medium. Water is too versatile in dissolving and again in transporting a water-based medium, like in active transport and again like in passive transport manner. Another very important property of water is water can be act as a raw material or an starting material for many reaction, which means if water is lost from them, that reaction may not be takes place. For example, in photosynthesis, water is a raw material here. If water is absent from here, glucose cannot be made here. If glucose cannot be made here, life may not be continue here. Energy generation from that of ATP may not be takes place. By that, water is an essential raw material of photosynthesis. So, one factor that determines rate of photosynthesis, the amount of moisture or water presence. Notice this one. Water is very important in the process of digestion. Breaking of larger molecule into that of smaller one by the process of hydrolysis. larger molecule split it or that break down to that smaller one by adding water. For example, starch, which is a larger molecule, adding water into that respective monomer, glucose and the glucose molecule. Protein, by adding water molecule into that of amino acid. And again, lipid, by adding water molecule, and again into fatty acid in that of glycerol. Water is very important in digestion. Water can be act as a raw material here. And again, the another thing and very important, complex and very important for the life is organic molecule. Student, do you remember what means organic molecule to mean? Well then, they are a molecule that contain both carbon and hydrogen at the same time with another derivative elements like carbohydrate, like lipid, like protein, and the nucleic acid are some example of organic molecule. Carbohydrates. Do you know what means carbohydrate or hydrated sugar to mean, students? Carbohydrate can be abbreviated as this formula, CnH2nOn, where N is a number of carbon greater than 3. When we say carbohydrate, carbohydrate is one part of organic molecule that contain element hydrogen, carbon, and the oxygen. When carbon and the oxygen is present in 2:1 ratio. Students, do you know where carbohydrate used in your body? Very good. One, carbohydrate is considered as the common respiratory substrate for the cell, which means most amount of energy is released from carbohydrates. And again, carbohydrate is very important as an energy storage. An energy storage in plants, which is special carbohydrate starch. An energy storage in animal, which is considered as glycogen. Else, it is very important in building structure, like a plant cell wall, which is made from a larger carbohydrate called cellulose. A fungal cell wall, which is made from a larger carbohydrate chitin. A bacterial cell wall, which is made from that of a complex of carbohydrate and the protein, peptidoglycan. So, carbohydrate is very essential. Carbohydrate can be classified into 3 main types based on their content of sugar units. These are monosaccharide, disaccharide, polysaccharide. Let me see them one by one. When we say monosaccharide, it is the simplest and the most important carbohydrate containing one sugar unit only. There is one sugar unit only, considered as a basic unit of carbohydrates. It is used to build larger another type of carbohydrate when they are joined together. When monosaccharide become joined together or bonded together, it is very responsible in forming larger carbohydrate, a base. This is why we say a basic unit. Based on their carbon content, we can classify monosaccharide into that of 3 main types. One is triose. When we say triose, a carbohydrate containing 3 carbon number, which we call C3H6O3, containing carbon 3. Another, pentose, containing 5 carbon. Most important carbohydrate that is found in nucleotides. For example, ribose, which is found in RNA, deoxyribose, which is found in DNA. They are monosaccharide too. Hexose, containing 6 carbon sugar. So here they contain 6 carbon sugar. It is a common building. Most part of carbohydrate is made from this one. Another larger carbohydrate is made from that of hexose parts. For example, glucose, galactose, and the fructose is some part of an example of hexose part of carbohydrates. So, based on their functional group, all monosaccharides are aldose and that of ketose. Some part of aldose part of functional group is glyceride, ribose, glucose in the galactose part. This part, aldose part, glyceride, ribose, glucose in the galactose are, they are said to be having aldose functional group. Here, ketose part are dihydroxyacetone, ribulose, and again fructose are containing this like functional group here. And again, this structure are when glucose and else carbohydrate can be found in straight form. But in solution form, glucose and the other monosaccharide can be formed as a ring structure. For example, glucose can have two ring structure, which I mean alpha ring structure and the beta ring structure. Student, do you know what means the difference between alpha and that of beta chain to mean? Good. When you say alpha glucose, the only difference between alpha and that of beta glucose here is the position of OH that is found at carbon number 1. Here is, it is positioned to that of the bottom, OH is. Here, but OH become positioned to that of the above. Well done. The else fructose contain only one ring form, which is alpha form only, which is positioned at the bottom. Good. Another very important type of carbohydrate is disaccharide. When we say disaccharide, containing 2 sugar units, especially from that of hexose part, that are joined by alpha 1,4-glycosidic bond. Mean there is a linkage between carbon number 1 here and again at carbon number 4. This is why we say alpha 1,4-glycosidic bond mean at carbon number 1 and at carbon number 4 here there is attachment here. The bond that is formed between 2 monosaccharide at carbon number 1 and carbon number 4 releasing water molecule is said to be this one or glycosidic linkage. For example, maltose, which is extracted from that of barley seed, made from that of 2 glucose units. Sucrose, which is made from that of glucose and the fructose, whereas lactose, which is made from that of glucose and that of galactose molecule. Except sucrose, the rest monosaccharide and the disaccharide are reducing sugar. They react with that of a Benedict solution in the giving red precipitation. Well done, student. Another type of carbohydrate made from thousands of monosaccharide is polysaccharide. The name by itself is, it is made from many monosaccharide molecules joined by special condensation reaction, releasing water molecule. Student, do you know what by means some advantage of polysaccharide here? Well, polysaccharide is very important in storing energy. For example, starch and storage carbohydrate in plants, glycogen and storage product in animal. It can serve structural carbohydrate too, cellulose, structural component in plants, peptidoglycan, structural component in bacteria. So, polysaccharide is very important structurally again as storage matter. Well done. We see some example of polysaccharide. Starch is one of it. When we say starch, it is a mixture of amylose and amylopectin. Both amylose and amylopectin are a polymer of alpha glucose, but arranged differently. When we say amylose, it is unbranched starch molecule, unbranched. The only linkage that is found here is alpha 1,4-glycosidic linkage is found here only. There is no side branching here. But here, when you say amylopectin, it is branched one. It is branched. There is one alpha 1 for glycosidic linkage. It is bit complex. It is branched one. Another linkage alpha 1 6 glycosidic linkage is found here. The branched nature of amylopectin allow it to become more easily to become hydrolyzed to release energy. Very good. Student, the structure of starch is adapted as an storage because it is very compactly stored. And again, it is insoluble in water. It cannot be affected another cell metabolism. It cannot be diffused out. By that, it is considered as storage. It is adapted for its function. Good. And another very important type of polysaccharide is glycogen. Do you know glycogen? Well then, glycogen means storage product of carbohydrate in animal. It has similar, most probably similar with that of amylopectin structure, but it is highly branched than that of amylopectin with more alpha 1 6 glycosidic linkage. Student, which do you think may be release energy or metabolically active, plant or animal? Well, animal is highly metabolically active because of the presence of more branched nature in glycogen, which may be alpha 1 6 linkage. It is easily hydrolyzed to release energy from that of a glucose during respiration. By that, animal have high metabolic rate than that of plants. Well, the most important another part of polysaccharide is cellulose. Student, do you know what differentiates cellulose from that of starch and that of glycogen? Well, both starch and the glycogen are a polymer of alpha glucose. But here, cellulose is the most abundant and the hardest polysaccharide, which is made from that of a beta glucose, joined by beta 1 glycosidic bond. This nature, we say beta because the position of OH in that of hydrogen atom at carbon number 1 is reversed or upside down. This is very important. Unbranched nature and the upside down reverse of carbon in that of hydrogen at number 1 allow to become hydrogen bonding. That is very important information of microfibril in where? In plant cell wall. If it is branched, microfibril may not be formed here. So plants may not be strengthful. Plant cell wall may not be made. Beta nature is very important for this character or this nature of microfibril formation. For example, let's see this one. Let's see this one. There is a reversed here. At carbon number 1, the carbon number 4, OH become reversed. There is releasing of water molecule found here. The reversing or that of upside down nature of this carbohydrate cellulose is very important information of plant cell wall microfibril formation. When we see by transition electron microscope the detailed structure of plant cell wall, it can be looks like this one. Microfibril formation is because of the beta nature, upside down position of the carbohydrates. Student, in this lesson, we have seen the difference between organic and inorganic molecule. And again, we have seen some property of water with their biological importance. Additionally, we have seen types of carbohydrates, monosaccharide, which include triose, pentose, and hexose, disaccharide, maltose, lactose, and sucrose, and again polysaccharide, which include starch, glycogen, and cellulose. In our coming lesson, we will see lipid and protein. Until that, goodbye, student.